Mathematics 1, Sketching Graphs. An equation models the behaviour of a relationship over a range of values. Sketching an equation helps us to see the important areas of a relationship. We'll start by sketching straight lines. We need 2 points to draw a straight line, and the easiest 2 points are often when x equals 0 and when y equals 0. For a sanity check, we could add a third point to make sure that the 3 points are collinear. As an example, let's take y equals x plus 3. When x equals 0, y equals 3. When y equals 0, x equals minus 3. And when x equals 1, y equals 4. Let's put these on a table. So when x equals 0, y equals 3. When y equals 0, x equals minus 3. And when x equals 1, y equals 4. We plot the points on a curve and then we can draw the line through them. And in this case you can see the line goes through all 3 points, so our sanity check, which is this point here, works well. Another reason for sketching graphs is to find points of intersection. 2 straight lines with different gradients will always intersect. A sketch can help us find where. As an example, let's take y equals x minus 2 and y equals minus 2x plus 3. The gradients are different, so we know they're going to intersect. If you could travel along y equals x minus 2 from x equals minus infinity to x equals plus infinity, everywhere on the line it will be true to say that y is equal to x minus 2. And if a friend of yours could travel along y equals minus 2x plus 3 from x equals minus infinity to x equals plus infinity, every point on the journey it will be true to say that y is equal to minus 2x plus 3. Where the 2 lines cross, and at no other point in the universe, both y equals x minus 2 is true and y equals minus 2x plus 3 is true, what that means is the values of x and y in both equations are identical. Let's sketch that. In this case, because we've got 2 equations, I'm just going to use simple values for x. So when x equals 0 in the first equation, y is equal to minus 2, x is equal to 0, y is equal to minus 2, and in the second equation, when x equals 0, y is equal to 3. So the y is equal to 3. When x equals minus 1 in the first equation, y is equal to minus 3, x equals minus 1, y equals minus 3, and in the second equation, minus 1 times minus 2 gives us plus 2, so that means that the y value is going to equal 5. When x equals 1 in the first equation, 1 minus 2 is minus 1, so x is equal to 1, y is equal to minus 1, and in the second equation, x is equal to 1, so that will become minus 2 plus 3 is 1, so y is equal to 1. So now we'll plot that equation. We draw the first line, we draw the second line, and you can see the point of intersection there. Now let's see what happens for higher order curves. We're going to take equations of the form y is equal to ax squared plus bx plus c. To sketch this, we're just going to choose a series of x values. So as before, we'll draw a table and we'll put values of x in. So when x is equal to 0, y is equal to minus 1. X equals 0, y equals minus 1. When x equals 1, we've got 1, minus 2, minus 1. So when x is equal to 1, y is equal to minus 2. When x equals 2, that will be 4, minus 4, leaving you with minus 1. So when x equals 2, y is equal to minus 1. When x equals 3, we'll have 9 minus 6, which is 3. Minus 1 gives us 2. So when x equals 3, y is equal to 2. And when x is equal to minus 1, this will be 1. This will be plus 2, so that gives me 3. 3 minus 1 is 2. First of all, we draw the crosses, and then we draw the curve through the crosses. The final thing I'd like to consider in sketching graphs is the intersection between lines that aren't necessarily straight. So let's take y is equal to minus x squared plus 2x plus 11 and y is equal to minus 3x over 2 plus 6. As before, we'll create a table and fill it with values of x and y. Having got our points, we plot the quadratic curve and the straight line and then you can see the points of intersection. In the examples, we've used fairly straightforward linear and quadratic lines. Both these have straightforward algebraic solutions which we could have found instead of sketching them. But if it was an equation of a sort that we've not met before, we can still sketch them just to give us an idea of the behaviour of the relationship.